Hi, how you doing? Science denial is dangerous enough, but what's even more destructive to a delusional mind is flat earthers using scientific terms to try and explain unsubstantiated claims of a flat earth, with literally no understanding of what science is. One example is perspective, or the law of perspective, to try and explain why objects such as boats and the sun go over the horizon, or are blocked by the horizon. But what happens when the actual law of perspective is applied to the flat earth? Well, a buddy of mine and one of my favourite citizen scientists, Al Kay, has done exactly that. The video I'm going to show you is an absolute must-see for all flat earth debunkers and for anyone who just wants a better understanding of perspective and observations of our planet. The video is awesome. I love it. Al Kay produces great videos and is far better than me at explaining complicated scientific principles. He's almost at 1,000 subscribers, so watch this video. I guarantee you'll enjoy it. Then go and visit his channel and let's get him to 1,000 subs. Here's the video. Thanks for watching. Enjoy.
Since Flat Earth started appearing on YouTube about 5 years ago, the arguments really haven't evolved. We find several tropes being repeated ad nauseum, such that they've become literal memes. One of the most vapid and overused examples is the claim that the horizon always rises to eye level due to perspective. The claim that the horizon rises to eye level has been debunked many times before, through demonstrations of horizon dip. In this video I want to take a slightly different approach and demonstrate that the law of perspective itself debunks the flat earth claim that perspective causes the horizon to rise to eye level. Here are the points that we need to know. Perspective is the apparent change in angular size of an object depending upon its distance from an observer. In layman's terms, the object appears to shrink uniformly as it gets further away from the observer. This is something we all experience and it's easy to understand. We can accurately calculate this effect using the law of perspective as shown here. Depending on our needs, we can rearrange the formula and calculate the linear size, angular size or distance of an object, so long as we have the remaining two parameters. We can see these formulas on the website, which I'll be using for the purposes of the video. Let's say we have a pole that stands 6 feet high, then 6 feet is our linear or actual size, represented by g in the diagram. If we measure the angular size of the pole as indicated, we can calculate how far away it is from the observer. For this example, let's say the pole has an angular size of 0.5 degrees. This gives us a distance of 687.5 feet. However, the minimum threshold of angular resolution of the human eye is stated to be around 0.02 degrees. Anything below this angular size cannot be resolved. This limitation is a core part of the claim that the horizon is a vanishing point caused by perspective. What we can do then is take any object for which we know the linear size and use the formula to find out how far away it must be in order to reach the vanishing point caused by the eye's inability to resolve information below the stated angular size of 0.02 degrees. Let's see how that works out for the 6-foot pole. So our result is 17,188.73 feet, or 3.25 miles. That's good. This is the approximate distance agreed upon to the horizon for a 6-foot observer. By utilising this same technique, we can determine the distance to the horizon for any observer height without the need to measure an object. The linear size is just the height of the space between the observer's eye level and the ground. So this is our technique. We input an observer height, set the angular size to 0.02 degrees to represent the point of convergence denoting the perspective horizon, and this will tell us the distance from the observer to the horizon, allowing us to test the flat earth perspective claims against reality. There are two approaches we can use. We can calculate for a selection of observer heights, then go test those results and see if the predictions match reality, or we can take an existing observation and see if the horizon distance matches the calculated value. Let's continue by using the second option. We will use a sample observation of sufficient height with a clear horizon in a known location from which we can determine if the distance to the horizon matches that predicted by the law of perspective. And what better example can we use than that of one provided by a flat earther who claims to be able to see too far. Enter J. Tolan Media and his now rather infamous infrared observations taken from an aeroplane. Now, J. Tolan's claims have already been thoroughly debunked in terms of the locations he identifies in his videos. He either lies or is terribly mistaken, but either way, others have correctly identified the areas visible in his footage. This saves us some groundwork and we can get right to the point. All we need is the height of the observer and an identifiable location at the horizon. We're going to use J. Tolan's so-called Hudson Bay observation. In that video, J. Tolan shows himself to be at 28,000 feet as he is just slightly southeast of London, Ontario. He claims to be able to see all the way to Hudson Bay, which is about 1,000 miles away, but in reality the horizon could be seen at the very northern part of Lake Huron, just beyond Drummond Island, Michigan. So if we're being very generous and extend his line of sight to the shores to the north, we get a measured distance between 250 to 260 miles, depending on the exact angle. So, J. Tolan's claim is around 1,000 miles of visibility, but the true horizon is much less, even when exaggerated for generosity, at around 260 miles, only a quarter of the claimed distance. Now we're going to calculate where the perspective horizon should be and see how these values compare. 28,000 feet is our linear size, and 0.02 degrees is our point of convergence, as already discussed. Let's see if the observed horizon is where it ought to be, or if it falls well short of the expected range, disproving the flat earth perspective hypothesis. And the result is over 80 million feet. That is just under 15,200 miles. It's patently obvious that the horizon is nowhere near 15,000 miles away. That is more than halfway around the stated circumference of the world. For comparison, the northern tip of Alaska, the furthest piece of land in the general direction of J. Tolan's view, is around 3,000 miles away, and that is a mere fifth of the expected horizon distance on a flat earth according to the law of perspective. This is bad news for J. Tolan and all other flat earthers. Even if he could see 1,000 miles, as he claimed, that's still only 1/15th of the distance to the flat earth perspective horizon. And the actual horizon we do see is just shy of a measly 1/60th of that distance. And it should be noted that any point along the ground before the horizon is necessarily below eye level in this model. So when you say the horizon rises to eye level, but you can only see 1/60th of the distance to the point where your eye level would intersect with the ground, it is impossible for that closer point to be at your eye level. And even that generous 1,000 mile view is still a massive shortfall for this example. So there it is. Perspective kills the flat earth. But we aren't quite done. Now it's time to talk about the other approach. We used a specific example here to show that reality does not come close to matching the predicted perspective horizon. But the more astute amongst you will realise that the real issue here is that the perspective horizon is so ridiculously far away that it can never be seen from high altitude. Every single time someone looks out of an airplane window, no matter how clear their view is and how far they can see, they are looking at a horizon that is impossible on a flat earth. A horizon which is ridiculously close for the perspective model, and by definition, well below eye level. And it only gets worse for flat earth, because so far this only deals with the altitude of commercial flights. When we start getting into the realms of high altitude balloon footage, things get really bad. For example, one of Dwayne Kellam's balloons reached an altitude of just over 114,000 feet. Using the perspective method, the distance to the horizon from Dwayne's footage is 61,853 miles. That's 2.5 times the circumference of the Earth. And whether you believe in that circumference or not, with a viewing radius this large, all of the continents on flat Earth should be visible in any such footage. Even the ISS can't compare to that. I'll leave it up to you guys to go look up the perspective horizon distance from the ISS. So, to sum this one up, the claim that the horizon rises to eye level when using the perspective model fails massively. The distance to the horizon is so huge once we start gaining elevation as to be absolutely absurd, and these distances are easily falsified by any high altitude observation. In turn, horizon dip is also substantiated and flat Earth is debunked yet again. Any time you take a flight, you can easily prove flat Earth is false, thanks to the law of perspective. Oh, and by the way, about that generous estimate of a 260-mile horizon for J-Tolan, guess which model actually predicts what he saw? That's right. You know why? Because cute little fairy tales can't alter the measurable geometry of the Earth. Thanks for watching.